My fellow Angular developers, can I ask you a favor? Please, please, please stop overusing the centralized store pattern in applications that don't benefit from it at all. Now, I'm a fan of the pattern myself and I use it. I will show you how I use it, but I have the impression that in the Angular ecosystem, the centralized store pattern has been largely overused for all the wrong reasons. So in this video, I'm going to get into the pros and the cons of this pattern so that you can decide for yourself if it's a good fit for you, your team, and your project. Welcome back to the Angular University channel. I'm Vasco. I have helped hundreds of thousands of developers to learn Angular since 2016. My mission is to teach advanced Angular concepts in a simple and uncomplicated way, demystifying Angular. If this is something that you are interested in, then subscribe here to the Angular University channel. Let's then dive straight into the content, and let me start by clarifying that I am not against centralized stores in general. I use them, so it's not like I'm against them. I will show you how and why I use them in my company, onlinecoursehost.com. Now, note that this video is not about a particular implementation of the store pattern, such as NgRx, NgRx Signal Store, NgXS, or Redux. This video is about the pattern itself in general. So this knowledge is applicable for all those libraries that you might be using. So it's a video more about application architecture. Now, I assume that you are already familiar with centralized stores, but I'm just going to give you here a quick summary of what exactly is a centralized store. So it's like an in-memory database where you store your application in a central place outside of any component. So for example, imagine here my application, my platform, has this in-memory application state. It's a course platform, so it has things like courses, lessons, the user, some coupon codes, pricing plans, questions and answers, etc. This is the typical type of data that we are going to store in a centralized place in our application. Then different components in the application can consume the data via the notion of selectors. So this is an NgRx store application. So we have this notion of selectors, and other centralized store libraries have other notions. So the notion of selector is specifically to the RxJS implementation of the centralized store pattern. This is how we fetch data from the store. If we want to modify the data in the store, then we need to dispatch it an action. So we cannot just modify the data directly. We need to dispatch an action object. And again, this notion here of an action is specifically to the RxJS version of the centralized store, which is NgRx store. Other store implementations don't have this, such as, for example, NgRx Signal Store. There is no notion of actions, but we need an equivalent way to send sort of a message to the store telling it that we want to perform a certain action in it that is going to trigger the modification of the store data. Then we also need a notion of a reducer. Again, the notion of reducer comes from Redux. That's the original library in the React ecosystem that triggered the whole centralized store pattern approach in many frameworks, such as, for example, Angular. So here the notion of a reducer is a way of patching the in-memory database state in response to triggering an action. So we need a way to modify the state. And those are the four components of a centralized store. We need to define the state that we store in the database. We need a way to fetch the state. In this case, these are selectors. In the case of NgRx Signal Store, it would be computed signals. We need a way to trigger actions to the store. In the case of NgRx Signal Store, that would be behavior methods in the store. We need a way to patch the state, and we also need a way to perform side effects in response to data modifications in the store. In the case of NgRx store, that comes with NgRx effects. In the case of NgRx Signal Store, then we can just use the signal effect primitive from Angular to define a side effect. We don't need a specialized API for that. And this, in a nutshell, is what the code of a store-based application looks like. There is a centralized in-memory database. There is a level of indirection to modify the data. We can reactively get notified if the data in the store gets modified. That, in a nutshell, is the solution. Let me show you an application in action to further cement these concepts. Here is the same platform that corresponds here to this code. We can see it here running. So here is how this works. Whenever you reload the application, the data, such as the courses that you see here on the screen, they get loaded from the backend and they are saved inside the store. Then notice that when I access a particular course, the course details, such as, for example, the course lessons, and here which lessons this user has completed, that information is fetched from the backend and saved inside the store. But now notice the following. Whenever we go back here to the initial page, the data was already there. So we didn't fetch it from the backend again. There was no loading indicator. The same here when we click on course, it's instantaneous. We did not load these course details again from the backend. There was no loading indicator this time around. Instead, all the data was inside the store, and we can see the store in action using here the Redux DevTools. You click here on the Redux tab, and you can see here the store by clicking here on the state tab. And you can see here the state that is available in memory. In the application, you have the courses, the lessons, the user, etc. And you have here a log of actions. So let me give you an example. If you want to modify the data here, for example, of this lesson, if you want to modify this lesson title, then we are going to need to dispatch a lesson here to the store. Notice that when I click save, there is a new update lesson here in our actions log. If I click on the action, we can see the payload of the action. We can see that the changes is just changing the title in a lesson entity. And if you click here on diff, you're going to have the diff in the main state that the action has caused. So in this case, the only difference in the state of the store was that for this lesson entity, the title moved from this title scratched in red to this title in green. So this is how a centralized store works at runtime. This is the type of developer experience and user experience that it can give you. And now we are really getting to the crux of the matter, because as you can see, going back here to our application, this implementation using a store is not for free. So it's a lot of code. This is complex. You have to write your application in a completely different way. You have to create actions, reducers, selectors, effects. Writing effects can be especially tricky. You need to know quite a bit of RxJS to do that. And overall, it's just more complex and more complicated to write an application this way. So the key thing to understand about centralized stores and their use in an application is that they are not for free. There is a lot of boilerplate and complexity. There is a cost to pay for using a centralized store in your application. And there are trade-offs. It's not for free. It's definitely not a silver bullet. So then now let's talk about when should you use a centralized store and why. So let me give you 3 main reasons that I think justify the use of a store in an application. Reason number 1, you want to improve the user experience as much as possible, and you are willing to pay the development cost for that. For example, you want to develop a public-facing internet product such as this one, where you want to give the users the best possible user experience. So minimal loading indicators. Whenever the user does a save operation, the save happens in the background without a loading indicator blocking the user interface. That's the kind of premium user experience that you want to give to your users. If your application is a typical enterprise application that is meant for a captive audience, it's not a public internet product, then probably this does not apply to you. So that was reason number 1. Now reason number 2. You want to make sure that your application does a minimum amount of requests to your backend, as little as possible. So in the case of this application, you only fetch the data once for the lifetime of the user session, you keep it in memory, and if you modify it, the data, you update the store and you send back the data to the backend as a side effect, but you are not going to continuously reload the same data again and again as the user navigates through the application. This again improves the user experience, but also reduces to its minimum the number of backend requests, and this is especially important. For example, in the case of this application, it's based on Firestore, so if you check here the calculator, you're going to see that we are being billed by document writes, by document reads, so these cloud costs can stack up quickly in this type of databases such as Firestore. So you might want to design your application from the very beginning to make sure that your cloud costs are going to be under control for the foreseeable future, even if your application grows to have a very large number of users. Again, if your application is a typical enterprise application with a limited number of users, say up to a few thousands, probably it doesn't make any difference to you the amount of HTTP requests that hits your backend. That's just not a lot of requests. Also, there are other ways to avoid HTTP requests that don't involve using a centralized store. That's just one way of making sure that that happens, that we reduce the number of requests overall in the whole application, but you also have other solutions for that. Now, before I give you reason number 3, the final reason, I want to ask you, if you are enjoying this video and you are getting value out of it, please go ahead and give me a like here on YouTube. It means the world to me and I would very much appreciate it. Thank you so much in advance. Now, reason number 3, your application might have a very specific UI that benefits from a centralized store. In this type of application, you have the same data being projected in different forms at the same time in the exact same screen. So let me give you here a simple example. Here, this particular application does not benefit specifically a lot from reason number 3, but let me just give you here an example. If I update here this image, I want this to be propagated also here. But of course, this is a very limited example, so I'm going to ask you to imagine, for example, a mailbox type application where you are marking the different messages as read and unread, and you have here an unread messages counter. Well, these are two different representations of the same data, right? One is a summarized count, the other is a list of items. So you want to keep all that data in sync. You don't want every component to know about every other component and have direct interaction between those components. So what do? If you have multiple views of the same data in the same screen at the same time, you pull that data out of all of those components and you put it in a centralized place. Then you modify it there in the centralized store, and those data changes get propagated and reflected in a consistent way across all the views of the data. So multiple views for the same data, that's the typical reason number 3 for wanting to use a centralized store. And that's it. Those, in my opinion, are the 3 main reasons why you would want to use a store in the first place. If your application does not meet any of these criteria, then you probably don't need it, and most likely there is a much simpler way of doing what you are trying to achieve without using a store solution. Now, let's talk about something else very important, which is when not to use a store. Going back here to this application, I just want to give you an example that you don't need to use the store everywhere in your application just for a matter of consistency. I think that would be insane in most cases. So you should use the store in the screens and in the part of the user interface that really benefit from it. And if you have screens that don't necessarily need it, then don't use it there. Let me give you an example. Here, in the course platform, we have used the store in the most important screens that are used both by the students and by the course creators, such as the view course screen, the watch course screen, etc. These screens here are the main screens of the application where most of the data is being fetched from the backend. Most of the user experience is there, so we have used the store in this part of the application, but we have opted for not using the store solution in these simple admin screens that are only visible by the admins of each course website and that are very rarely used, that are not a source of a lot of requests to our backend. These screens were not built using effects, actions, selectors, and reducers. They were built with much simpler code. We just make a request to the backend to save the data, such as here, for example, the user profile. We just make a request, save the data in our backend, and if there is some change that needs to be done to the store, we just dispatch an action to update the store, and that's it. But this very simple screen, this was not built using the typical 4 store constructs of NgRx store. Another typical situation where, in my view, you should not use a store is just to be able to benefit from on-push change detection. The reality is that the vast majority of applications don't benefit at all from on-push change detection. I have done a whole different video about it. You can go and watch it here on my channel, but the summary of what that video says is that using a store introduces a lot of accidental complexity, so the store solution is going to make your application significantly more complex. You don't want to take a simple application that can be implemented using much simpler ways and add a store to it just to be able to turn on push change detection everywhere, which you didn't need in the first place because you didn't need the extra performance. So that would be insane, in my opinion. It would be a complete yak shaving scenario where you are adding things and complexity to an application just to benefit from features that you don't need in the first place. Alright, so let's quickly summarize what we have learned about centralized stores. Use them only if you really need them. Assume that you probably don't need them. If your application does not match any of the 3 reasons that I have listed here, probably you don't need a centralized store. You will know when you need it. Don't use the centralized store as an enabler for on-push change detection in applications that don't need the performance benefit in the first place. The store comes with complexity. It's not a silver bullet. It's a trade-off between code complexity and some features. If you don't need the features, then you definitely don't need the complexity as well. Now, I think that I know what some of you would say in the comments, which is, but Vasco, what about NgRx Signal Store? It's a much simpler store implementation that is signal based. It doesn't use RxJS, so the complexity that comes with it is much lower. It's indeed much lower. It's much easier to use than NgRx Store. You don't need RxJS, but still the complexity that comes with it is significant. It's a lot of boilerplate. It's a lot of indirection just to modify the data of your application. So again, even in the case of NgRx Signal Store, don't use it unless you have a match for one of the 3 reasons that I have listed here. If you are thinking of using NgRx Signal Store just to be able to benefit from deep signals, then you don't need to. You can instead use this very lightweight utility called NgRx Signal State that allows you to benefit from fine-grained signal-based reactivity without having to use a store solution. Check out this video here on the channel that I made about it. I encourage you in general, in the long term of your development career, to try to develop a deeper level of knowledge about the technologies that you use. So don't just learn NgRx Store and NgRx Signal Store and call it a day. Instead, go one level deeper and try to understand when to use a centralized store and why. This type of knowledge lasts a lot longer and it's going to help you a lot to understand new technologies that come along. If you want to learn Angular in a simple and uncomplicated way, check out my courses from beginner to advanced at the Angular University. Thank you so much for watching and I will see you next time. Cheers everyone!